The C++ language is a language with a quite long history actually. And it has gone through several revisions during its development. The latest two revisions, one was made in year 2011, and uh, and the standard was called C++ 11. And the last revision it was made was on 2014, and the standard was called C++ 14. And after the revision has been made, um, various compilers has been developed to conform to these particular standards. And the most popular open source C++ compiler is called G++. And on your system, you can find out where G++ is installed by type where is G++. And by the time I'm making this video, the version of the G++ that's installed on my system by default is 4.8.4. You can find out the version of the G++ by type G++ -v, and then you can sort of see the version of it. And by default, this version does not actually support the C++ standard 14. C++ 14 standard. So if I do std equals to C++ 14, and then let's try to compile a test program. It's telling me that the std C++ 14 is not recognized. But this version of the G++ can recognize the C++ 11 standard. So if I change 14 to 11, it compiles. The reason that it does not recognize C++ 14 standard is because the version of the G++ installed on my system is not high enough. So on my system, I have to make an upgrade. I have to sort of update my G++ actually. So to make this upgrade, it's not too difficult. All you have to do is to type this command to add this Ubuntu toolchain-r/test to the repository. So I'm doing an add apt repository, and then add this particular PPA to my repository. So by the time I'm making this video, the new version of G++, which is version 4.2, is still in the test phase, so it's not automatically installed on my system. But I can sort of install it manually by myself by doing the following steps. So first, add this particular PPA to my repository by using add apt repository. And then do a sudo apt-get update. It's going to take a while. And then the last step is sudo apt-get install G++ -4.9. Don't forget about the dash. And then it's going to make the installation. And now if I do a where is G++ -4.9, and then it's going to tell me that it's installed under user bin G++ -4.9. So that's going to be the latest version of the G++ compiler on my system now. Of course, if your default compiler is already 4.9 or above 4.9, you don't really have to make this upgrade. You can just use the standard, use the C++ 14 standard automatically. So I'm gonna test1.cpp, and this time it's gonna compile, and it recognizes the C++ 14 standard. And or you can use GNU++ 14, and this is also conforming to the C++ 14 standard with some additional features. So you can use either option, this one or this one, with the G++-4.9 compiler on your system. For developing C++ codes, we're going to use a integrated development environment called, or IDE. And the IDE that we're going to use is called Eclipse. And integrated development environment is quite different from the editor that we have been using, the EI or the Emacs or VI editor that we have been using. We have talked about. So the integrated development environment gives you a graphical user interface, allows you to sort of to develop large projects easily. So we're gonna look at how to write C++ codes inside of this Eclipse IDE. And Eclipse is actually a quite portable IDE. You can get different versions. You have a version for the Windows, a version for the Mac, and also a version for the Linux. So it allows you to develop not just C++ codes, but also Java codes, PHP codes, Fortran codes. So Eclipse is like a IDE that's with lots of plugins. So if you need a particular development environment, for example, if you need Fortran, all you need to do is to get those plugins to add on to the Eclipse core code, and then you can sort of get the development environment for Fortran, for example. And this is sort of their website, Eclipse. It's been around for quite a while, and it's quite mature, and it's supported. The development is supported by lots of large companies. And it is actively developed and maintained. Lots of people are using it. For example, if you click on getting started, you can sort of look around. You have quite a substantial documentation, very detailed documentation, You can sort of use it for self-study or something. And so if you would like to sort of download packages, for example, and then it's gonna give you lots of widely used packages. For example, Eclipse IDE for C++ developers, and then Linux version. You have different kinds of bits, and then here you can sort of select which version you wanna. If you are using Windows, then switch to Windows, and then the package you download can run on Windows. And then if you use a Mac, you can sort of use Mac, download a Mac version. So for my case, I'm gonna just click on this one, 64-bit Linux, and then it's gonna take me to this particular page. If I want to download it, I just click on download. But I already have a version. I already downloaded this package here. It's a table. If you want to sort of extract the content from this table, you can go to the command line, for example. The stuff that the table I put my table in on these downloads. So if you look at I have this table here. So in the command line tools that we talked about in my previous videos, we talked about how to extract from a table. Just do tar xzf and then Eclipse. So after it finishes, it's going to generate a subdirectory called Eclipse, and then you can switch to that subdirectory, do a listing, and then you're going to see the executable. But you cannot read it. It's a binary code, I think. But you can just run it now. And then it's gonna start the IDE. So I'm gonna cancel it because so for now it's the extracted subdirectory is under my download, but you can move it to a system-wide directory. For example, OPT. You can move it to OPT, for example. So I have moved my Eclipse to root OPT. So the root OPT allows you to store some additional software packages which are could be quite large, could be quite large software packages. And then if you look at the OPT Eclipse, you're gonna see the executable there. And then what you have to do is to add this path to a path environment variable by doing an export. Export path equals to path colon OPT Eclipse. So every time if you type Eclipse, then it's gonna find it under this. The system is gonna find it under this particular directory because this directory is already in your path environment variable, so it allows you to find it. So that's one way for installing Eclipse on your Linux operating system. There's also a second way, is to use sudo apt-get install. What you want to install is Eclipse itself together with Eclipse CDT. The CDT is the kind of environment for developing C, C++ codes. So if you sort of install both packages, it's going to ask me if I want to continue. It's going to occupy some disk space, that kind of thing. I'm going to answer no because I already have it installed. Maybe not the latest version, but it works. So that's the second way for you to install Eclipse on your system by just using apt-get install eclipse-cdt. Don't forget about this package. So you can sort of start developing develop C++ codes in this IDE. It is the Eclipse itself carries a very extensive documentation. So and the interface is quite intuitive to use. So we're gonna sort of look at how to write some very simple C++ codes in Eclipse in a later video. But Eclipse is definitely something that you might want to look into if you are sort of interested in doing substantial code development on a Linux platform. If you are on a Windows platform, there's also another IDE that's used quite extensively. That's Visual Studio. It's developed by Microsoft. So Visual Studio is a very good IDE for Windows systems. Eclipse also runs on Windows systems, so you can also use Eclipse on your PC. And on a Mac, you also have another IDE that's called Xcode. Xcode is also a IDE that's quite easy to use, but Eclipse also runs on Mac also. So that's going to be our development environment. We're going to use Eclipse as our IDE in future videos. So after you start Eclipse, it's going to present you with this dialog box. Especially if you are running it for the first time, it's going to ask you what's going to be your workspace. The workspace is going to be the directory on which it's going to store all the project files. So in Eclipse, every code has to be every source code has to belong to a certain project. So you start working on a certain code by opening a new project, and those project files and all the related metadata, that kind of descriptions of those data. How do you actually compile the data? How do you compile the source code? That kind of data are stored under a certain directory in your workspace. And by default, it's going to generate a new directory called workspace under your home directory. So you can specify a different directory if you would like to. But I'm just going to use the default and then just click on OK. And then it's going to give you this particular interface. You are looking at the main Eclipse interface, and it's just like every other application that runs on Ubuntu. If you move your cursor to the panel, you're going to see the menu bar that's associated with the Eclipse application. And in particular, you can go to Help, and it's going to give you quite extensive documentation about the. So for example, if you can go to C++ development user guide, and then before you begin, get started, and then concepts, tasks, references. It gives you very detailed explanation about how to use the Eclipse IDE to develop C++ codes. So that's in your help menu bar. underneath help contents, and also you can search for help, that kind of thing, and tips and tricks if you want to sort of check for updates. That's kind of important if you want to, because Eclipse allows you to update itself. So every time if you have a new release of Eclipse, you can go here and check for updates, and then it's going to automatically install those updates for you. You also have Eclipse Market, in which you can sort of look for plugins. That's kind of important to you, and you can also install those plugins. Install new software allows you to install those plugins, those add-ons to Eclipse core, and uh, so let's look at the interface for for some time, and so basically that's the main interface of the Eclipse IDE. On the top, you can sort of see a sequence of menu bars, a menu item, toolbars, a set of toolbars. So some of them are quite important. For example, this is new, allows you to generate new projects. Right, C++ project allows you to generate new C++ projects. It's a save files, save all the files, printing files. This is called build. For now, it's grayed out because there's no source code for it yet. And then you also have a run button. If you want to test your code, see if it runs or not, you can just click on it. Then it's gonna run your code. And all those buttons are all quite useful. On the left hand side, you have this called Project Explorer. So it's gonna list all the source codes, the files. It's gonna list all the source codes for belongs to this particular project that you are working on, and then the white space in the middle is for displaying your source code itself. Actually, it's gonna be the main area that you are gonna work on, and then there's an outline. It's gonna list all the gives you an outline about the whole project, their components, and then it's actually tabbed. It has different tabs, and we're gonna look at how to use those tabs later. And in the bottom, you have also different tabs. So problems, if your code actually has bugs, for example, have errors, it's gonna be displayed here. Tasks, console is kind of important because the kind of a display, the feedback from your code. For example, if you print out something to the terminal, that kind of thing, those kind of printouts from your code are going to be displayed down here. And some other tabs are also quite useful. So now let's try to generate a new project. So let's click on this triangle, and then we're going to do a new C++ project. We're going to open a new C++ project, and then it's going to open this dialog box. You have to choose a project name. Let's just say test1. We're going to use test1, and the location of the test1 project is going to be under your workspace. So it's home project workspace test1. So all the source code that belongs to the test1 project are going to be stored underneath this test1 subdirectory. And then you have to select a template for your project. So what you can do is to do empty project. You just choose an empty project. Project type, it's asking you for a project type. You just tell it it's an empty project. Later on, we're going to look at some kind of MPI projects, that kind of thing. So. And then toolchains. Toolchains is the tools that you're going to use for compiling the code, actually. So C++ codes are different from the shell scripts that we have sort of talked about before. You need to sort of convert them into binaries. So the text that you are working on is called the source code. The source code is sort of in a text file that can be read by human, but the machine cannot sort of directly execute those text files. It's different from shell scripts. Shell scripts are text files readable by human, and you can also execute them directly inside of the terminal. But for C++ codes, you have to sort of explicitly convert those source codes, those text files, into a binary executable that can be read by machine. And those binary executables can be sort of run inside of the terminal, just like an ordinary command. You have to go through this additional step of compiling the codes, converting the text files into binary executables, and that conversion process is called compiling. And the compiling is going to require a compiler. And the toolchains is basically specifying what the compiler is going to be, and all the associated kind of add-ons. Because the compiler doesn't work alone, it also requires some libraries, that kind of thing. So to link to other directories and to link to the other shared libraries, to use other kind of a preprocessor, that kind of thing. So it's asking you to specify a toolchain. In this case, because we are not using GPU programming for this particular example, we're just gonna use Linux GCC as our toolchain. So GNU compiler, C++ compiler is gonna be the compiler that we're gonna use. And then you click on next. So it allows you to sort of specify different platforms, either a debug release or a release. If you usually just want to pick both of them. Debug is gonna, when you compile your source code into a binary executable, you can specify different flags to the compiler, and the kind of binary codes generated by the compiler is gonna be different depending upon those flags that you pass on to the compiler. And for the debugger release, the compiler is gonna sort of look carefully about the source code, and then it's gonna generate codes that runs pretty slow, but it's gonna give you some sort of additional information about how the code is working. The release version is gonna be compiled by a different set of flags that's gonna allow you to optimize the source code to the extreme, and it will allow your code to run very fast, but it's not going to print out some debugging information, allows you to discover potential problems, that kind of thing. So release is like when your product is finished, you want to give it out to users, then you do a release version. And usually you want to just work on a debug version, so you can sort of interact with the code more often. So we can just pick both. It's going to generate both the debug version and also the release version, and then we can just click on finish. Now it's going to generate a test subdirectory, and then includes. Those are the system default includes. System default includes. So let's try to sort of write some codes. Let's try to write some codes. So if you want to add some source code, add some source code to a certain project, you can right-click on it. So you can right-click on it. Right-click on the project in the Project Explorer, and then you can have a new, and then you have a header file, source file. We can add a header file, for example. So I'm going to explain what header files are, but for now let's just generate a one header file. Let's just call it a header, headers.h. So header files are usually ended with .h. So .h means that it's a header file, and it allows you to specify a certain template. So you have a bunch of some choices. Default C++ header template, and then if you click on finish, you're going to have a new file. It's called headers.h, and in the middle panel you're going to see the content of the headers.h. So your file name is being displayed here, and the Eclipse has already written some lines for you. For example, if ndef headers underscore h, define headers underscore h, ndef. So if you look carefully about the first line, headers.h, you can see a small plus sign here. If you click on the plus sign, it's going to expand the entire lines, all the lines. So it's displaying the header name, and then it gives you some additional information. When it was created, who created it, this kind of thing. These lines are called comment lines. It doesn't really, it's ignored by the compiler, but it actually allows the human who read the file to get some information about this particular file. So a comment line in C++, you have two ways of writing a command line. This is one way of doing that. So you start by you start by you start a if you start a multiple line comment by doing this, by using a slash star, and then you can just write whatever text you want to put in there. If you don't have enough lines, you can just return and then keep typing. It's going to allow you to document the purpose of this particular source file, and it's going to allow you to write the author, date, this kind of information into the source file. And if you want to collapse this multiple line comment, you can just click on this, and then it's going to collapse it. Because most of the time you don't really want to sort of spend your screen for displaying those comments. That's one of the ways for writing comments. There's another way for writing comments that's using slash. Two slash next to each other starts a new command line. So if I try to write some codes into it, include bits stdc++.h. So here I have written a line that starts with a hash or a pound sign, include, and then a pointed bracket, a pair of pointed brackets, and then some text between the pointed brackets. So if I want to sort of explain what this particular line is for, I can just put two slash and then just explain what this line is for, to include all the headers provided by C++ std standard library. So you can use this slash to provide an explanation for a particular line, or you can just put a slash here and then include the headers. So you can anywhere that you want to start a comment, you can just use slash. So that's going to be our first line. Every line that starts with a pound sign is going to be processed by the preprocessor. So a pound sign include actually means what? It means that I want to add this particular text file into my project. So include means just means that I want to take the content of this particular file. This particular file is actually a text file. Actually, I want to take this particular text file. I want to include that content in that particular text file into my project, into this file actually, into this file. So the preprocessor is going to take the content and then just take the content of this file and then just put it in this entire file. But instead of for you to write all the content by hand, this kind of include command allows you to automatically include the content of another file without you typing anything, typing very few things. So all you have to do is to just include this line, then everything is included. We're going to look at this kind of thing later on, but you can also think of it as some kind of logic. If I have not defined, if not defined headers underscore h, I'm going to define this thing. So this is actually a logic. You can sort of see if I did not define this particular variable, I will define this particular variable, and then that's gonna, and this is endif. So this is the entire thing actually is one block, one if block. You can think of it as one if block. So the purpose for this particular if block together with this define is to prevent include the same file multiple times. So we're going to look at how to use this preprocessor later on, but the purpose for this block, for this if and def define and then endif logic here is to prevent you to include one file multiple times, because this is just a very simple example. We're gonna but this headers.h file that we're working on now might be included by other headers. and other headers might include other headers. So it is possible that this particular header could be included in multiple times in one file. So to prevent that kind of situation from happening, you need this logic. So this is one line that we have added. And we're going to write another line that's called using namespace std. But this line is going to be ended with a semicolon. So we're going to talk about a namespace later. But the purpose for this particular line is to expose all the names that's defined in the std namespace, the standard namespace, to the program that's going to be used by to my project. So I can use all the names that has been defined in std. And this is actually a command. So a command or a statement. A statement has to be ended with a semicolon. That's kind of the convention for C++ codes. So that's going to be our first header. Our first source file is called headers.h, and we're going to save it. We're going to save it. Now let's try to add a C++ source code to this project. Again, right-click on the project name, and then new. But this time it's going to be a source file. Instead of header file, we're going to pick a source file. And then I'm going to just say it's a test1, test1.cpp. Create a new source file. Because .cpp is sort of the standard extension for a C++ source code. And the template is sort of the default C++ source template. You have some other choices, but let's just use the default. And then let's just click on finish. Now you have a test1.cpp that's been added to your project. Again, so Eclipse has already added some command lines at the beginning for you, but you don't have to sort of look at it. You can just ignore it. So inside of this test1.cpp, the first thing we're going to do is to include this headers.h that we have just created. So how do we actually include a header file? Again, using include. But this time I'm going to use the double quotation. As soon as you type in one double quotation, Eclipse is going to automatically complete the other half, the other double quotation. So you don't really have to type two double quotations. Headers.h, it's going to be just under my current working directory, so it's just going to be double quotation signs. And then I'm going to define a function. So include headers.h is going to take all the content in headers.h and then put it right here. Put it right here. So the preprocessor is going to just do that. And then let me try to write a function. So every program has to have a function that's called main. So here I am actually trying to define a function. So if you want to write the body of the function, you have to use the curly bracket. So as soon as you type return, Eclipse is going to automatically pair the brackets for you. So if you have already typed the left curly bracket, you press return, Eclipse is going to put a right bracket right underneath it. So it's going to pair it for you. So what does it mean? I'm defining a function that's called a main. Every program has to have a main function. And this main function takes no input. So this parenthesis after the function name actually is a place for you to put input to this particular function. And then this thing actually in front of the function name is called the return type. The function is going to take some input and it's going to return something. The stuff that's going to be returned is a integer. So that's why an integer in C++ is represented with int. So it's going to take no input and return an integer. So that's going to be our main function. And let's try to write the body of the function. So inside of this function, we're going to define some variables. So how can we define variables? We have two ways of defining variables. I'm going to sort of type the keyword auto, and then let's define a variable that's called I. and I equals to 1, and then end with semicolon. So auto is a kind of type that's that's a very special kind of type actually. So in principle, what I want is a integer. So if you actually type int I equals to 1, it will also work. It will also work. Suppose I define a new integer that's j equals to 1. So, but the auto has the kind of special property that it allows you the compiler is gonna deduce the type of the variable based on the initialization value. So you don't really have to sort of specify the type by yourself. You can just allow the compiler to figure out what's actually the type of this particular variable for you based on the initialization value. So this kind of type deduction by the compiler, the automatic type deduction by the compiler, is a feature of modern programming language. So the benefit for doing that is that it minimizes mistake made by humans. So for some of the major sources of bugs coming from modern programs is for type mismatch. So if you are actually sort of, if a function requires a certain type but you give it a different type, you get a type mismatch. So a better way for solving this kind of problem is to allow the compiler to figure out the type for you instead of for a human to explicitly specify what the type actually is. So the auto command or the auto keyword allows you to tell the compiler that I want you to figure out what's actually the type of I by yourself based on the initialization value that's being sort of given to this particular variable. That's one of the benefits for using this kind of automatic type deduction. A second benefit for using automatic type deduction is that some types, especially in C++, some types can be very, very long. So it could be sort of related to some kind of class that's kind of nested, and so if you want to type a very long type name in your source code, it's error prone and it's tedious. It involves lots of typing. But if you ask the compiler to figure it out for you, you don't really have to sort of type that very long type name. And there's also a third benefit for using this kind of automatic type deduction, which is that it forces you to initialize the data for you. So another major source of bugs coming from in source code is from uninitialized variables actually. So uninitialized variables have undefined values. Some compilers may automatically initialize it for you to a certain value that you may not want. Maybe it's going to initialize it to 1, but what you really want is to initialize to 0. So many programmers can, even very experienced programmers can forget to initialize a variable, and that's another major source of error or bugs. So if you actually don't specify the initializing value, then the auto command has no way to figure out what's actually the type of this particular variable. So it's going to give you a compile time error. So it's going to ask you to explicitly initialize it. And if you actually try to build this project, it's going to tell you you have a error. So let's try to sort of introduce some more additional variables. Let's call it, that's I. We have sort of introduced a integer. Let's try to define a floating point number, for example. Let's call it f. F equals to. Suppose I want to define a floating point number. So how do you actually tell? How do you actually tell the auto that f is actually a floating point number. You give the initialization value a suffix that's f, then it's going to tell this f letter following the number that you're actually using to initialize this variable is going to tell the compiler that what I want is a floating point number. So if you actually move your cursor over to f, the IDE is actually telling you f actually has a type of float. So that's sort of the type that's inferred by the compiler. The IDE is basically some kind of front end of the compiler, so it allows you to invoke some of the capabilities of the compiler. So basically it's actually telling you this is actually a float. And then if you move your cursor to I, so let's try to sort of compile this particular source code. Before we do that, let's try to return a type. That's just gonna return 0. I'm gonna return an integer, but let's just try to compile this code. But compiling the code won't pass. It's gonna give you some error messages. The reason is that you haven't actually specified the C++ standard that you're gonna use. So let's right click on the project and then go down to the bottom item. It's called properties. And then it's going to give you this dialog box. And you have lots of options now. So C++ build, you have to sort of click on C++ build. And then you have a bunch of options underneath it. Build variables, for example. Manage configuration. This is for, and then environment. And then logging. And then settings. So this is the settings. So what I'm going to do is I'll probably have to specify what's going to be the compiler. So the command, what we want to do is to use G++-4.9. That's going to be our compiler. So if you don't have G++-4.9 compiler, that's sort of the latest version when I'm making this video. You might want to sort of look at my previous video how to actually install it. And then some options. We'll need to sort of add one more option here. We're going to use std. We're going to add one more option here. Dash. So it's not really allowing me to. I'm gonna go to this MISC submenu, and here I'm gonna add my flag. I'm gonna specify the standard to be C++ 14. I'll use this new standard. And then if I click on OK and let me compile it. So it's giving me two warnings. So basically two warnings is basically unused variable. If unused variable, I define a variable, but I'm not using it in the following. So suppose let's try to define some more variables. So f is like a float. But if I do auto, I'm going to define a double this time. Double equals to 3 point. So how do you actually define a double? You give it a initialization value and then follow it using the letter D. Here, if you move your cursor over to the variable name, it's going to tell you it's a double. And then if you want a long double, for example, a long double, let's call it LD. The L, actually, no D, just the letter L. You just follow the number with letter L. And if you move your cursor, it's going to tell you it's a long double. So the type of the variable is automatically figured out by the compiler. In this particular case, the IDE is actually telling you what's actually the type of the variable. So now let's try to sort of print out those variables, the values that's stored in those variables. So let's do a cout. So cout is basically the standard output standard output in usually it just means the screen. So what you want, it's an object defined by defining the C++ headers. So it's a name that has been sort of defined already, so you can use it. It's an object that has been defined already, so you can use it. And how do I actually use cout? I use it by sending some variables to it. Suppose I want to send I to it. So it's then this time it's going to print out the content of I, and then it's going to I'm going to ask it to print a return character return. So end of line. So ENDL actually means end of line. So I'm going to send I, the variable I, to cout, and then followed by the end of line. So I'm sending multiple stuff to the cout object. The first stuff I'm going to send to it is the variable I, and then I'm going to send the end of line object to cout. I'm going to do the same thing for F D LD. So now let's try to save it. We're going to save it by clicking this button and then build it. So now all the variables has been used, so it's not telling me I have unused variables, that kind of thing. But let's try to run it. Let's try to run it. If I move my cursor to this particular button, it's gonna tell me run my MPI project. It's a project that I built before, and but that's not the project I am working on right now. I don't want to run my MPI project. I want to run the test1 project. So how do you actually change that? You go here. There's a triangle here. You can click on it, and then you have a run configurations. Click on yes, and then you can just pick the program that you want to run. It's going to be test1 debug, and then debug test1. That's sort of the binary, and then just click on run. So it's going to print out a 1 first, that's I, the value in I, and then float F 3.14, and then double and long double 3.14159. So it's not really printing out all the digits that you give it to you give to the variable. We're going to look at how to actually specify those digits later. How to specify how many digits you want to display in a little bit later. So basically that's one of the ways for you to define variables. So you have to sort of use the auto to ask the compiler to figure out what the type actually is, and then you have to initialize the variable. Don't forget to initialize the variable, otherwise it won't compile. So now that's all those variables are actually numbers. All those variables are actually numbers. So suppose I want a string. Suppose I want a string, a character string, for example. I want a string that's called it's called S1, and then I'm going to initialize it. Initialize it using the word hello with a space behind it. So you have a type that's called a string. It's actually a class. And the name of the variable is called S1, and the type of S1 is called a string. And you initialize it using this curly bracket, using this pair of curly brackets. This curly brackets is called uniform initialization. So you can use the curly brackets to initialize some stuff that's not exactly sort of defined using auto. Auto is asking the compiler to figure out the type for you. But if you actually use auto here, it's not going to work. It's not going to work. The type of S1 is not going to be string. It's going to be something that you don't really want. It's called an initialization list, but that's not exactly the stuff that you want. What you really want is a string. And how to actually initialize a string? You initialize it by using the curly brackets with the stuff that you want to put into the string listed in double quotation sign. And of course, you have to end a statement with a semicolon. So now S1 has a type of a string, and it's initialized to hello. So that's a string. And how do we actually use arrays? When we talk about shell programming, shell scripts, we talk about arrays. And in shell script, an array can actually contain different types of data. But in C++, it's a bad idea to put different types of data into an array. And usually you use an array in a way that all the elements in that array are of exactly the same type. So suppose I want an array, I can use the vector. I can use the vector type. A vector is basically the elementary way for you to represent an array inside of a C++ code. So what's going to be the elements? What's going to be the type of the elements that's inside of this vector? Suppose you want integers. So how do you actually specify that? You specify that with a pair of angular brackets, and then you put into it the type you want for each of the element. So this way you define a vector of integers, or it's basically just an array of integers. And then let's just call it A. And suppose we would like to initialize it. We'd like to initialize it. 1, 2, 3, for example. Let's give it one more number, 4, 5, maybe one more number. And end it with a semicolon. So now you are actually initializing a vector of integers with 5 numbers. So if you actually pay attention to the syntax, here you are actually initializing a string with a sequence of characters. Here you are initializing a vector of integers with a sequence of numbers, and all those initializations are put into these curly brackets. So the curly brackets allows you to initialize stuff in a unified way. So maybe let's define another string. Let's call it S2, and let's call it word with an exclamation mark. So here we have defined a bunch of numbers, 2 string, and an array of a vector of integers with just 5 elements inside of this array. So now let's save it, and then let's compile it and see if we get any errors. So build finished. Problems? No problems, I think. No problems. Right.